Now that we've talked about the theory of Scrum and we talked about the artifacts and how these things work together, but that remains the question: how this framework really works in solving complex problem using adaptive solution? So let's just start by looking at this imaginary project. So I have here a simple product, which I just call it, balls and boxes. So in this product, I have, a bunch of different sports there. So I have a tennis ball, I have a baseball ball, I have a hockey puck, and I have a ping pong or a table tennis ball. So different types of them. And so the product we want to build, let's just say you've been given, this product. Your boss came to you and told you, I want to build this shape. I need you to fill all those balls in those boxes, and just build a shape, a house of boxes like that. So we have little boy Jack who wants to take a box every day to play with the balls in the playground. So how do you go about estimating? And in as it happened in most cases of our product development, you may just be given this task and say, okay, I need to know in the next 5 minutes how many boxes you need, and I want you once I give you those boxes, I have them, I have lots of them. I'll give you all the boxes you need. I just need this to be done in 5 minutes. Isn't this the reality that we face in product development? Very generic high-level requirements, many complex components work together, and short time frame to deliver. So how does Scrum solve those complex problems? So typically, in our old way, our structured way of estimating, or waterfallish way of estimating and thinking, you might think and go and say, well, okay, I'll start by maybe measuring the area of the box, and then start, look at the perimeter, measuring the perimeter of each different ball or the area of each ball, and go through many, many complex calculation to figure out how many you can fit of these. And then you're going to spend a lot of time trying different methods of calculation, and chances are it's going to take a long time to come to a reasonable estimate, and most likely you'll also get the number of boxes correct and will not be able to finish. So how do we do this in the agile way of working, and particularly with Scrum? So like I said, our product backlog here, I have 12 ping pong balls and 6 tennis balls, 5 hockey pucks, and 4 baseball balls. So, in the agile way of thinking, instead of spending time trying to think of, making different calculation to how many can fit, I would just start and, look at the balls from a relative size, yeah, and then give them a weight compared to their relative size. So ping pong is clearly the smallest one. So I give the ping pong ball a size or a weight of 1. I can relatively say that a tennis ball is 2. I don't need to measure them exactly and figure out is it 2.5 or maybe 2.75. It doesn't matter. Just by quickly and rapidly eyeballing, I think you would agree, if we just want a quick measure, if I say the ping pong is 1, I can say a tennis ball is 2. And then relative to the tennis ball, if I bring the hockey puck and look at them, clearly the hockey puck is bigger in dimension, so it's clearly not 2, but probably also it's not 4. So I think a relative weight to the tennis for the hockey puck would be 3, is reasonable. And then lastly, if the hockey puck is 3, then I can say fair enough that the baseball is 5, just because it's bigger in size. So without, like I said, without we don't need to spend a lot of time thinking or measuring anything, just by eyeballing. So now I was able to quickly give a relative weight based on the size of my balls in my product in in a very quick way. And now so now I have this backlog of balls. I have 12 of the ping pong, and I have six of the tennis, and I have five of the um, hockey pucks and four of the baseball. So if I wanted to collectively figure out how many the total weight of my product, so I just can simply multiply the weight by the number of backlog items. So 1 by 12 is 12, and 2 by 6, 12, 15, and 20. So the whole pocket here is basically full of 59. I have 59 storyboards. Now, if the rule that I was told by the your stakeholder, you need to spend 30 seconds to fill each ball or less, and when you fill it, the box should stay intact. You can squish the balls, but the box should not be. You can squeeze, but you cannot squish the box. And also, the lid has to close, tight and nicely. Um, so now let's just start by filling those boxes and see how many we can come up with. So I pre-filled them, but I'll just start now uh, doing filling them one by one. So remember, we have four different categories, and this is the total number that we have. So I'll start, if I'm going to start with box one, and we'll start with a hockey puck first, and then maybe I'll use another hockey puck, and I'll see if I can use a tennis ball here. You can see it's probably not closing. So I used two hockey pucks, so now I have six, and maybe I can use two more ping pong, so we have a eight, and maybe I'll just stop here. I don't think anything else can fit any ping pong ball. Maybe I can use another ping pong ball. Okay, so I have two hockey pucks and four table tennis ball. I don't think there's enough room, so this box is filled with two of the six and four of the one. So I have built a total of I filled 10 story points in box one. All right, now let's take another box here. So in this box, I'll just start by putting the baseball, and you can see it's barely can fit. I can squeeze it, and the box remains intact, so I am complying with my requirements and close it. And it looks like once you fill it with one baseball, there's almost no room for anything, not even a single, uh, you know, table tennis. The box will not close, so I'll just get rid of it. And then here, box two, I was able to only fill one baseball. So here I had five, and then if I just go into another fill a third ball, and maybe this time I'll try to use a combination of I'm going to use a tennis ball and maybe another hockey puck. So now two and five, two and five, and I don't, maybe try to be more smart. So let just the hockey puck sit at the bottom. So there's three, five, and chances are there's no more room for hockey. So I can start using some table tennis. So five, six, seven, eight. Let's see if it's gonna close. Uh, maybe not. So I can just move this one. And here, with this round two, so now I have only one of each, one hockey, so this is three, and one tennis is five, and one ping pong, so this is six. So in box three, I filled up six story points. So now I have filled three boxes, and each one I, managed to fill certain amounts. So if I now start by looking at the average, my average performance over a sample of three boxes. So just see here. So I have my calculator and at the average. So 10 plus 10 plus 5 plus 6, so actually 21. And then if I divided this by 3, so here, so those are together 21. If I divided them by 3, so we're talking about 7 point 7, exactly 7. So 21 by 3 equals 7. So at an average, I can say, okay, my average capacity for a box is 50 is 7 based on, actual fitting of free ones. And we know that we have 59 of them. So now if I divide 59, I just divide 59 divided by 7. So I will get, so 59 divided by 7, that's equal 8.4 something. So 8.4, doesn't matter. So now I can confidently say I probably need 9 boxes, right? To fill all my backlog of balls. But you see now the difference here is that I didn't spend a lot of time measuring or doing anything just by eyeballing and giving a relative weight to each ball and quickly doing the work, filling a sample of boxes. I now came to a pretty reliable estimate as how much boxes. I didn't need to go through all the boxes, but I know now that based on my estimates that I would need 9 boxes. Pay attention that now these estimates are not based on theoretical calculation. It is based on actual performance, right? Like we've actually did the work. I did the work of filling my product, my balls inside the boxes. So this is where we say the theory of empiricism. My estimates are not based on just any hypothetical equations. It's based on actual performance using this same product, using the same complexity of my stories. And so it's pretty much reliable. And that's the difference. And this is how the Scrum and the theory of empiricism, the mechanism of it works in solving those types of complex problems. So now let's just put a name to what we've discussed throughout this simulation product. Okay, so let's put a Scrum term to what we saw. So we said like we need a 30 seconds and an empty box. What does this resemble in the terms of Scrum? So it's clearly we're talking about something that is, has physical and time dimensions. So a 30 seconds plus an empty box is basically our sprint. You can see it's literally a time box. It's a box, and we have a fixed time that we have to finish the work in. So that's a metaphor for a sprint. And what does the ball in this product represents? It's the product backlog item because, as you've seen, we've categorized our products into 4 different categories and give them a relative weight. And then when we say a box is filled with balls, what does that represent in the terms of Scrum? That's not actually an increment because as you can see, it's like, I don't need in reality, if I'm building this product and I want, my little boy Jack go to the playground with a box every day, each increment will help contribute to the overall structure, but I really don't need to finish the whole structure to let Jack start playing. So as you can see, each increment is additive to the previous increment, and each increment on its own is usable and functional and brings value to the customer. And then last but not least, we talked about the filling rules, that you can squeeze, but cannot squish the box, that the lid has to close tightly. So what are these represent in terms of, the Scrum terms? This is basically the definition of done because this describes the quality and the state of quality for each of my increment that I delivered. I have to make sure that box is not squished and the lid is closed tightly. So that is the definition of that's in a nutshell how Scrum helps in solving those complex problems. I hope you liked this example.